Welcome back to STS. In today's video, we're going to look at the derivative using the constant rule. Simply stated, when you have a constant that creates a horizontal line, and the slope of a horizontal line is 0, thus that means the derivative is 0. So let's take a look at an example. Here we have f of x is equal to 6, which can also be written as y is equal to 6. And by just taking a quick sketch, this is our xy coordinate. If this here is the line y equals 6, we see that it's a horizontal line, and because it's horizontal, we know that the slope of that line is 0. But let's go ahead and put this into our difference quotient just to see if we can come to the same conclusion. So y prime is equal to the limit as h approaches 0 of the function where the independent variable is now x plus h minus the original function where all of that is divided by 6. Again, we write this limit as h approaches 0. Well, if we look at our original function, there are no x variables here, so when we rewrite, it's just going to be 6 minus the original function, and again the original function itself is just 6, and this here needs to be divided by h, and I detected I made a small error here to start. That shouldn't have been a 6. That in fact should have been an h. Alright, as I begin to or continue to evaluate, I still have this limit as h approaches 0. I evaluate 6 minus 6 to give me 0 over h, and I see that as h approaches 0, well, we know that that h never gets to 0. But we're going to graphically take a look to figure out what this limit looks like, or what the limit actually turns out to be. So let's call up our calculator tool. Notice that I've already put in the function y equals 6, and here's the expression for the derivative. I'm using 0 over x because I'm not able to input a h or another variable in the calculator. So the second or the red line is going to be the expression for the slope or derivative, and the blue line is going to be the original function. Let's go ahead and click graph so we can take a look at what this is. Alright, as they're drawn in, we see that the blue or the original function is in fact a horizontal line, and we see that the red line, which is supposed to be the slope, is at 0. But let's go ahead and use the trace feature just to verify some of that, to verify those results. Alright, let's go down so that we're on the actual derivative. Notice that when x is 0, we see we don't have a value for y. In fact, when x is 0, we actually have, it's actually undefined, because we see here that our denominator can never be 0. Alright, but let's go ahead and trace along that. So let's come from the left hand side. As I'm approaching 0 from the left, as x approaches 0 from the left, we see it's at the -1 and 3/10. As I get closer and closer, we still see that the y value remains at 0. Once x actually goes to 0, we see it's showing nothing here, but that's really undefined. As I approach from the right hand side, here we're showing that x is 1.1 5/10. Again, as I get closer, you see the y value is remaining at 0, and we know from limits that just means that as h approaches 0, it never actually gets to 0. It gets infinitely close to, or infinitesimally close to 0, but never reaches it. So here we see graphically that the limit is in fact 0. So let's go ahead and put that 0 in place. So the key to take from here is that any constant, whether you have y equals 10 or y equals 3.14, when I look to find a derivative of that, the derivative of any constant actually comes out to be 0. Alright, that sums it up for this video by Speller Tutorial Services. Please subscribe to our YouTube channel for any updates and also for the new videos. And as always, thank you for watching.